Okay, so we've had our system powered up. We've tested the infrared detector. We've got our display working. So now I think it's time to get our switches wired up. So we're going to wire up our rev switch, our clip switch, and our jam door switch. So let's move that out of the way. Okay, so the rev switch is a single pole, single throw switch. We need about 12 inches of wire to get from it to the main board, so I'm using a 12-inch section of pre-crimped wire, and I'm just going to cut the crimps off the ends here. And again, we're going to strip 1/4 inch twist. And so, if you remember, I just cut the wires off there when we were getting the shell ready. So there's already a blob of the original lead-free solder on there, so we can utilize that. And we have best results if we tin our leads beforehand. And depending on whether you're right or left-handed, it kind of depends on the best way to do this. If you have some heat shrink, you can put that on. It'll make things a little cleaner, but in this case, we're just going to go for it. And again, being behind the camera here is not giving me the best advantage to do real quality soldering, but I want to give you guys a front row seat, so we're doing the best we can. Certainly not going to meet any kind of NASA standards here. If you're interested in those kind of things, it does make quite an interesting read. Okay, single pole, single throw switch is ready. And then we just need to, and again, I mentioned these are Molex Pico Blade connectors. I wouldn't expect a hobbyist to be able to actually crimp these kind of connectors. It's like a $350 tool, but you can buy these pre-crimped fairly cheap, and they are very compact and space saving, so that's why I kind of like them. And we use them on the board just so that it makes it easier to get the board in and out if you're doing repair work. Okay, so he's ready. I'm going to reach up here and grab the clip switch, which is, I believe, identical. Single pole, single throw. And we only need about 6 inches of him to get to our circuit board. And so I'm going to take a single section of 12-inch pre-crimped wire and cut it in half. Yeah, I don't know if I introduced these before, but these are, I don't think they actually sell these anymore. This is a Leatherman Squirt E4, and Adafruit Industries laser etched these way back when. It's a bomb diffuser, so it's one of my favorite tools. Everyday carry, seen a lot of work. It's not an ideal stripper, but if that's all you got in your pocket, then you're set to go. Yeah, if I remember right, the story was they bought a laser system, and part of the way they paid that off is that you could send in like your iPhone and get it engraved, or they sold some engraved products like Leatherman tools. So I'm happy to have it. The blade's seen better days, but as far as a usable tool for a hacker or technician, it makes it great. The thing it really doesn't have is scissors, but I can get by without that. I've got just a little bit more than I'd like on it, so clip it down just a hair. And again, if you've got some heat shrink and you want to make this beautiful, you'd put it on beforehand and then slide it down over the solder joint and heat it in place. And everybody will think you're a pro. Okay, so that's the clip switch. Single pull, single throw. And then our final switch here is our jam door switch, which is a little different. And additionally, what we're going to do is grab, so we had a jumper installed that got us powered up originally as we did our testing, so we're going to grab that jumper. And we are going to use that, and check my notes real quick. So this needs to be 4 inches in length. And again, we were using this to turn on and off the system. The battery voltage comes through here and goes to the voltage regulator. Switch is a little bit different. It's got 3 leads on it. It is a single pole dual throw, and I can't remember if I talked about that earlier, but I think it's part of the braking circuit. If you open up the jam door, it kind of sets your motors up to brake, so they slow down quicker. And we're not going to do any of that, but that means that when the switch is in the open position, that these 2 contacts are open and these 2 are closed, and then when the jam door comes down and presses the lever, then the second 2 are connected and the first 2 are open. So what we really just need is those second 2 to make our basically our on-off switch here. And again, this sure is beautiful solder work, because we've still got the wire on there from the original. And such. Okay, so that's gonna do us. Bring our system in here. So this guy's kind of going to go in last. So we've got a little channel here. We're going to run a lot of wires through, and this guy will kind of sit on top of all that and keep everybody happy. So green wires was the the rev switch. It's got the farthest to go. And this is kind of one of the reasons I like doing this kind of mod instead of doing the higher capacity switches, because you don't have to do any shell cutting. You've got the original Hasbro parts in the original places that they wanted, so it kind of makes life a little bit easier. I'm going to go ahead and just lock this guy in place so he doesn't go anywhere. And then he's going to thread up, so any extra service loop we have is going to come down in here, and we're going to snake up behind the hand grip. We're going to come over, and there's some original posts for wires that we're going to utilize as we get ready, and then that's going to come up through this channel and down into the ref switch. Alright, let's see if we can put this back together now. We've got our switches in place, so clip switch goes into the clip header, which is the one farthest on the right. Got a rev switch, it's green, goes in the next one, like so, and then finally our jam door switch, which we picked red wires for, goes into the jam header. And previously we tested our photo header, so that one's already been tested. And if we throw some batteries in this guy, we should be okay, let's see what we got here. So we're going to want to be able to see our screen there. And if we press our jam door switch, power up, and we're interested in the rev switch here, the top blue one. And let's go from 1 to 0, and then our clip switch. Let's see on this one. This one will something help that to operate. Like so. And so the clip is actually the third blue one down. It's reading 0 right now, and it's reading 1. And of course we know our jam door button works, because if I release it, it turns on and off. So we've already tested our infrared sensor detector on the front end. The thing we really haven't tested is our Hall effect sensors. So let's start putting this guy back together. Okay, you've seen me struggle with this a couple of times. Let's see if I can get him back in place. Like so. And then he's got a cover. With 2 indexing pins and a screw. Like so. We're going to do our wires here in a second. Cover for the clip switch has a rib on it, which is part of the wall of the magazine. Corridor as it is, and it's got an indexing pin and 2 screws. So, Okay, and actually not sure how far I want to go here before we put our motors in, but let's see if we can. So there's a couple of posts in here that were original wiring posts. Right there. And what I'm going to do, I've got some blue sticky tack. Use this at work quite a bit. Let's see if this helps us out and keep things in place, just even if on a temporary basis. A little bit of experimentation here. And that should let us put our trigger in place. Trigger goes over that post, and there's a trigger lock here from the rev switch. So this can go in right now. Large silver screws with the kind of built-in washer to hold them in place. And then we have our lever mechanism with the catch spring. This one always trips me up. We're going through the middle. There's two posts here we need to get between. We'll go on top of the posts. We've got our spring, and then our kind of return spring here goes over this back post. And then we've got another screw with the built-in washer to hold that in place. So, rev switch. And so our wires are nice and clear, out of the way. Battery wires are going to come in like so. And I think we are ready to wire motors.